number 6 from the 2018 exam. This is the Maclaurin series 1, Paris series 1. Maclaurin series for ln of 1 plus x is given by this guy, the general term here. On its interval of convergence, this series converges to ln of 1 plus x. Let f be the function defined by f of x as x times ln of 1 plus x over 3. Write the first 4 non-zero terms and the general term for the Maclaurin series of f. Okay, so first 4 terms, well, we probably need to get ln of 1 plus x over 3, the Taylor series for that first, the Maclaurin series for that first. So, since this is the Taylor series, I'm just going to say Taylor series because Maclaurin series is a Taylor series. Okay, this is the Taylor series for ln of 1 plus x. Treat it like a function. Replace x with x over 3. So wherever there's an x, replace it with x over 3. That's what I did over here, okay? And then our function is x times ln of 1 plus x over 3. So this is a Paris series representation. Multiply everywhere by x, or multiply both sides of this equation by x. So each term multiplied by x, you get this. So this is the first 4 terms over here. Okay, you don't have to simplify, and I shouldn't have done that either because it's kind of hard, a little bit harder to get the general term. But this is 2 times 3 squared, this is 3 times 3 cubed, this is 4 times 3 to the 4th, this is 1 times 3 to the first power. So that's the pattern right there. The general term starts from positive. Let's assume we start from n equals 1, okay? So minus 1 to n plus 1, so it starts even. It starts positive and then become negative and then alternate. X to n plus 1 over n times 3 to n equals 1, 2, 3, 4, so on and so forth. So you could start from n equals 0. Your general term will be a little bit different, but here I started from n equals 1. And actually the scoring guidelines didn't say that you have to start from either one. It's actually ambiguous, so to make your life easy, I would just start from n equals 1. Okay? N equals 0 would be, if you start from n equals 0, this would be a little different, but it should be an acceptable answer as well. And actually, I was trying to say the scoring guidelines was not clear because they did write this, but do you start from n equals 0? Do you start from n equals 1? Or do you start from n equals 2 or some other value? You don't know, so I would write this as well. Okay, to be clear. The scoring guidelines are technically ambiguous. The answer that they gave without this is ambiguous. And to be honest, I would mark that wrong. Okay? So take what I'm saying with a grain of salt. Or with high importance. Up to you. Okay? 6b. I don't know what I was saying there, but anyway. 6b, determine the interval of convergence. Okay, so we first need the radius of convergence. That is just the ratio test, so we're going to use this answer over here. Do the ratio test, a sub n plus 1, divide by a sub n. Okay, you should get the absolute value of x over 3 as the limit. We set this less than 1, and so absolute value of x is less than 3. We got to check our endpoints, because it's this right now, but we don't know if it's equal or not at the endpoint. So we check x is minus 3, plug in minus 3 into here. I would write the summation notation, okay? This simplifies to 3 over n. Technically, you could move this 3 out, so it's 3 times summation of 1 over n. 1 over n is the harmonic series. We know it diverges, so I just wrote diverges because it's the harmonic series, okay? This in the scoring guidelines, they compare it to the harmonic series. I don't think that's needed, to be honest. This at the very, maybe do one more step and do 3 times summation 1 to infinity 1 over n. This is the harmonic series clearly, okay? And the other endpoint, x is equal to 3, you would get alternate harmonic series. Okay, so I would show one more step again, 3 times summation minus 1 to the n over n. So this is the alternate harmonic series, okay? And so we don't include this endpoint, but we include this endpoint. This is our interval of convergence. Okay, let's see what the scoring guidelines say. This one doesn't have as much description as the more recent test, so I'm not sure, but in my opinion, if I were the grader, this should be enough. Okay, because this is a harmonic series. This is an alternate harmonic series, okay? And part C, this was the easiest one actually. Let P of 4 be the 4th degree Taylor polynomial for f about x is equal to 0. Use the alternating series area bound to find an upper bound for P4 of 2 minus f of 2. Okay, so what does the alternating series error bound say? The maximum error is the first omitted term. So P4 is a 4th degree Taylor polynomial. The 5th degree term is the first omitted term. There's the reason I'm saying the 5th degree term and not the 5th term. Okay? Because, let's go back to here. This was our Taylor series, right? The general term. This is why I don't like that question. I like it when there's a summation notation, okay? 4th degree Taylor polynomial, it means that we stopped at n is equal to 3, because it'll be x to the 4th degree term. That's why I said it precisely, 4th degree term. 5th degree term is the term that we want to look at. That's when n is equal to 4. So don't get confused that this said 4th degree Taylor polynomial, so we choose n equals 5. No, we choose n equals 4 because we stopped at the 4th degree term. So the next term is the 5th degree term. That's when n is equal to 4. Okay, hopefully that's clear. That's the only trick to this one. Otherwise, n equals 4, so we get 2 to the 4 plus 1 over 4 times 3 to the 4th power again. N equals 4. Get rid of this alternating sign. Okay, so it'll be, x is 2 by the way. 2 to the 4 plus 1 over 4 times 3 to the 4th. That's what I wrote over there. And honestly, I would just leave it like this, but if you really want to simplify, it's 8 over 81. And that's it for this question. Not too bad. Hopefully this was helpful though. If you got stuck on anything, please give this video a like if it has helped you in any way. And hopefully I'll see you in another video as well. Bye.